Yeah, so today we'll discuss Kubernetes service, and we'll discuss, what this is, and how to create and things like this. So let's say you have created many pods. If you follow the microservice architecture, your one big system can be split into multiple microservices, and each microservice can have its own set of pods. These pods need to interact with each other. Let's say one microservice needs to call another microservice. For example, just say one example, but there could be many other examples of having pods need to interact with each other. So now the problem with this, and the ports need to interact with each other. Ports are ephemeral, what means that there's a tangent that it can crash. Once it crashes, then Kubernetes will start that pod immediately, a new pod immediately. So the new pod IP address will change because earlier pod had different IP address. It, for whatever reason, it crashed. New pod has some other IP address. Now there's another thing. There could be, as I said, one microservice can have multiple ports underneath, but I don't need to know, as a user of that service, I don't need to know about the set of ports which are serving that service. I just need to know one IP address. So now, how do you define this problem? If some set of ports, so let's say just for our understanding, let's call these backends, provide functionality to other ports. Let's call those front ends inside the cluster. So now, how do the front ends find out and keep track of which IP address to connect to for backend, so that front end can use the backend part of the workload? Now, that's one. So here we are talking about backend services which are consumed by the front end. Now, front end is also on the Kubernetes, backend is also on the Kubernetes. So front end will consume backend, but front end also needs to be consumed outside. So the outside users who are consuming front end, they also need to know one, unique IP address which does not change, and the problem becomes worse because the front end and the back end both are on ports, and ports can keep coming and going, and ports IP address will keep changing. So this is a problem. Now the solution of that is service object. So you create a service object. So what is service object? It is a resource for making single constant point of entry to group of ports providing the same service. If the front end is a set of front end, set of back ends, they are providing the same service. I just need to invoke that one IP address, and automatically internally it will figure out which port to connect and how to get the request served and everything. Now service has an IP address which can't change while service exists. Ports can keep coming and going, but service, as long as service, and when ports keep crash and recover and everything, the IP addresses of ports will change. But for service, as long as service object is there, the IP address won't change. So now, what does that mean? That means that no matter what happens to the ports, they are always accessible by the single IP address. This service is over the ports. Now, how that works and everything we'll discuss, we'll see in details. So client connections will be routed to one of the backing ports. Client won't need to know about ports behind the service. Ports can come and go, moved around, but services remain. So this is what client connect to the front end service. See here we are connected to the front end service. Then it has front end ports, and then actually this arrow should be here. My mistake, I will change it. So front end ports connect to the backend service, and backend service it connects to the pod. So this how it should be. This arrow should be down, and this arrow should be connecting to the backend service, because as I said, we won't connect to ports directly. So I will correct this diagram. So what is service? Call to ports via service is load balanced. There are various flavor of service, and we'll discuss most of these flavors. But how ports are assigned to service? Ports are assigned to service via label selector. Take an example. We have covered how, when we create the ports, each port can have a label, and here also in this coming example also we'll see that. Let's say you have one port which has this label app tips hyphen backend. So there are 3 ports, and the service also will have the same backend. So service in the service will have the label selector. So once we have the label selector, then this backend ports will be assigned to that service, and this service will be serving those ports. And there's another port which has some other label, and that label is different than the label selector defined in service. So a service won't be associating itself to this port. So let's do one thing. What we'll do is we'll create a pod, and we'll create a service also. So let's go through this YAML. And I think before this meeting, I was already doing that. So I can show you that. So there is a YAML, services one, service one.yaml. It's in the same project which I've shared with you. This type is pod, and it's a pod, YAML. This is a label. Main thing to note, this is a name. You can give any name. And label, this is the main thing to note. It's app Java tips backend. This is a container. I think we have been giving this spec for many times now. Now this is service. Now I have given this in one YAML. One thing you will notice, there are two types I'm defining in one YAML file itself. One is pod and second is service. So if I have multiple types I want to define in one file in one YAML, I have to separate those by three dashes. That's how Kubernetes will understand new resource definition is coming. So here I am defining, so API version is v1 for service at this moment. The kind is service. Here kind was pod, here kind is service. Metadata, name I can give anything. The spec, here I am giving ports. We'll discuss about the ports, but main thing is this Java tips backend, right? You see the label here, Java tips backend, and selector app Java tips backend. So it is selecting those ports. Selector is, it means selecting those ports which have this label, and this port has this label. What is port? The service to the outside world will be available on this port. But once I invoke this service object, Java tip service, once I invoke this service object, then internally service will delegate this to 8080 port of what? Of the ports which are having this label. And this port was exposing a REST endpoint on 8080. So this is how service and port are correlated. So let's do one thing. So let me show you that YAML here. I have already created that. So if you see here, so I created using this. Forget about this tips app and everything. So I will, why I'm not able to select. So ignore these, ports. Just focus on this port only, Java tips, because this is what I have created. So let me show you this services one.yaml. So this is the same thing which I was showing you. This is the port, this is the label, and this is a container spec. So I'm using the same image which I've been using for so long. And then this is a service, selector is same, and these are the ports, port and target port. And I've created created this service and port here. Once I created, I got the port, so I got this running. And then one thing which I have to show you is you got the port. Now I created a service. How do you get service? I say kubectl will get SVC. It will return the service. So this is a Java tip service which I was creating, correct? So this is what you were seeing here in the YAML. This is a Java tip service, correct? So this is the service which I had created. Now important thing to note here is in this service there is something called cluster IP, and you can see the port also which the service is opened on. This cluster IP is the IP which through which the service can be accessed, but within the Kubernetes cluster. If you are outside the Kubernetes cluster and you want to access the service, there's a different mechanism. There are a set of different mechanisms. We will cover some of those later. But for time being, using any cluster IP of any service, you can access the service from within the cluster. You can log into any node in the cluster and you can access this service using this IP address. And we have done that. So, but before that, you can describe any object in Kubernetes. So I described this service object. So kubectl describe an SVC, and this is the name of the service. And it says one thing which of course you can check the everything else, but one thing which I wanted to show you was the label, the selector. This is a selector label, and and it has will come to session affinity also later, and this is the port it is opened on, and it will request coming to this port will be sent to this port 8080 on the ports which it is associated with. Now how? So I got this, so I have this label here, and I wanted to show the same label in the port which it created, which is this, and you can see the same label is here also. Now let's go back to the here. It's the same thing which I showed you. Now I want to access this service, and I want to see this service is delegating the call or routing the call to the this service object is routing to the call to the port. So so this we have done. So I installed by the way Docker desktop. So now we'll be doing everything using Docker desktop. So now what I need to do is I can say kubectl exec port name and curl. So why are we doing the exec port name? Because as I said, right, let me go back here. This service, this cluster IP, the service has this cluster IP, and this cluster IP is accessible from within the cluster itself. Now this laptop is outside the cluster. So you can log into cluster. How to log into cluster? Go to any pod in the cluster. It need not be the pod created by created by this YAML. You can go to any pod in the cluster, and from that pod you can invoke the service using this IP address and this port. So this is what I am doing here. Here also you can see. So I say kubexec, and I go to Java tips. This is the pod I created, and then hyphen hyphen. Once I say hyphen hyphen, so I mentioned it here also, it means that kubectl command is over. Hyphen hyphen means kubectl command is over, and command inside the pod starts. So now you're running some command inside the pod itself, because you're logging into this pod and using kubectl. And once you log in, then what you want to do, you give that after hyphen hyphen. So hyphen hyphen curl minus s, and this is the cluster IP, and then this is the port, and this is the of course my service has this context, this path. So now so I using this I invoke the service, and I got the response. By the way, here you can see the response. So using service, I invoke the service using cluster IP on this port, and service was able to reroute the request to the port directly, because service itself doesn't have any REST endpoint running. It's on the port itself, which is this port. So this is how service in the port works, and how I can invoke the service. How I can invoke a endpoint on the port using the service object. Session affinity. So not just in Kubernetes, but in outside Kubernetes also, you would want. Let's say you have an application which is running on 5 machines, and those 5 machines, I'm talking about a normal architecture outside Kubernetes now. Let's say you are on Google Cloud or AWS or Azure, and those services are behind the load balancers. All clouds provide load balancer. So now when you are invoking, when a outside customer is invoking the service, the load balancer gets hit, and the backend instance of the service gets invoked. So now the client invokes the service again. Now it's not necessary that the instance which was invoked by load balancer the first time for the same client, the same instance will be invoked for that service, because the service is running on 5 nodes, and all the same service. It's the same service on 5 nodes, and all those 5 nodes are behind on load balancer. The same client invoking the same service multiple times can make load balancer hit any of these 5 nodes. There's no guarantee the same node, so the same client will hit every time. But now what we want is, we want if I am invoking that service, and it goes through load balancer, and if it's node 1, the next time when I hit the service, it should hold node 1 only again. It should not go to anyone else. So that's a scenario in load balancer and nodes. Same is the scenario in Kubernetes I want. So you have a service object, and you have ports behind the service objects, and ports are more than 1 ports. So if you have more than 1 ports behind the service object, and I invoke the service object, I invoke the service using the service cluster IP, and I want whatever port it hit for the first time, I want same port to be hit on the multiple invocations of the same service. So that's called session affinity. Uh, so I will just read it out. When we invoke a service which is on port having multiple replicas behind one service, then request can hit any port. So create replica set and service using below YAML. So what we will do is uh, now, so there, what I have not mentioned here is that I want to have it, write only what's one, one replica, same replica of the port every time. So, so let's go through this. So I'll create a replica set, and I will have this name, and the replicas are 3. And of course, the match label, Java tips backend, and this is the template which has this label, which is same as this, and the container, it's it's the same thing. Now I'm invoking a service, and this label is Java tips, and this is a sorry metadata. It's just a name. I can give any name, and this selector Java tips backend should be same as this. Now this name, because this is a replica set, so this name should be saved. This label should be same in the port template also, a port template label also, and it should be same in the service selector also. So so let's go through this. So then I will you will see I will just do it right now also. A service replica set and ports are created. So we'll see the desired count. I have given the desired count as 3, replica as 3 here. So we'll be able to see 3 replicas running of of the from the replica set, 3 ports running from the replica set. And now I show the service, and this is a cluster IP of the service, right? And I see the replica set had 3 desired and 3 current, so all are running. So whatever I wanted, those many number of ports, replicas are running. So now what I will do is from the Docker desktop, because I've been using Docker desktop, I will use the curl command, and it's the same, so it will same command which I've been using, so it will give the same response. What I can do is I can check the logs. So one thing which I did not do here, we did not tell here was in this I have not specified anything related to session affinity. So what I wanted to show you was, once you see the logs of 3 ports, and we'll see that it will hit 3 ports randomly, because here I have not specified session affinity, and once I hit these ports, it will I can see the request hitting different ports directly. Just give me just 1 second. Yeah. So so you will see this request which we are getting from this request which we are hitting, this is what we will use. It will hit different ports multiple times, because there are 3 replicas, 3 ports from the same replica set. So it will hit uh, any of these 3, and we'll see in the logs. But now so once we check the logs all port 1 by 1, we will observe each call can go to any of the ports behind the service. Now what we do is, but if we want session affinity, calls from one client should always go to same port. So here, so enter session affinity. So here in the service definition, in the under spec, we'll say session affinity client IP, correct? So everything else is same. So once is, and then we'll do the same thing. We'll create the replica set. This is the YAML which I've used, different YAML, and we'll check everything again, and we'll run the same thing again, and we check the logs. It will always go to one port only, correct? So now, and this is a command to check the log, kubectl logs -f, and then give the port name, correct? So let's do one thing. Let's start from here. Correct? So this is a YAML replica set with the service. So let's see that YAML first. Before that, let me know. I was trying something else. Let me delete that resource. CTL. Sorry, CTL. CTL delete. so that this goes away. kubectl get port, only one port should be there, which we need. Correct. So now what I'm going to do is I'm going to delete the replica set and the I'm going to delete this pod and the service. ctl get sec kubectl delete pod, and this is the code we have. This pod get deleted. kubectl delete sec. This is what I want to delete. This get deleted. So now I will let's look into this replica set with service. PLI replica set. Let's see that. Let's replica set with service. So let's see this. That. So you can see this. I have a replica set type and replica 3. This is Java tips backend label. Is the image and the service, which has the same label, which has the same this thing, label selector, and the rest of the things we discuss in the service are same. So what I'm going to do now is I'm going to create -f, sorry, kubectl. Let's see, ctl port all are running. Just give me 1 second. Right, so I created this port replica set which has this ports running. I can check the service also. As we see, so service also running, and this is the cluster IP address of this service. Correct. So now what I want to do is I want to go here and see. So this we have done, and of course we can check the replica set also. So we have 3 desired count and 3 are current and ready. So this looks good. Now what I'm going to do is going to look at the ports, this port, and see the log kubectl. What was the command for logs? I keep forgetting. Kubectl logs. Yes. kubectl logs. Yes. kubectl. I can say -f so that I can see it running. -f and port. Control C, Control V. And these are the things running. Same thing I will do here. kubectl logs -f port. And this is the second log we'll have running. kubectl logs -f port, and the third we'll have running. Cool. Okay, so let's give some space or something here. Now what I'm going to do is I'm going to issue this command kubectl exec kubectl and this is any pod I want to log in, just to log into the cluster. So I'm mentioning third pod. Let's see this. Sorry. FLT RSZP FLT, then curl -s stabbing. Okay, good. Third pod I've chosen. Let's see what happens. Right button. Or maybe I have not given this thing correctly. So given correctly. Let me copy paste anyway again. kubectl exec -fn curl -s. Okay, good. take something. First one I will take. Okay. Oh, sorry, my mistake. I did not give the right cluster IP address. I have to give the right cluster IP, which is this. This is a service cluster IP. So I have to give this. Now we'll see. So it hit this service, right? You can see returning text. Now let me run it again. Again, it's hitting same thing. Hey, why? Now it hit this. Hit the other one. Now let's see this. Hit another one. Let's see this. Hit again this. Now this hits another one. Again another one. Now it's another one. So randomly it's picking something, right? So this is without session affinity. Now what we are going to do now is we'll check the same thing with session affinity. So Control C, because I will be deleting the ports and the service and recreating with session affinity, and then we'll see. Cube CTL get replica set. So I'll delete this cube CTL. Delete replica set slash this replica set. Okay, spelling come down. Now service is also there. Cube CTL get SVC. Cube CTL delete SVC slash. Correct. So it got deleted. Now going back to the presentation, session affinity. So we have covered this. I just want to know the this thing. So this is replica set with session affinity. So ls replica with affinity. Correct. So let's see this. What is there? So only thing there is that I have mentioned session affinity colon client IP. Everything else remains same. So now we don't have any pod running. Cube CTL get pod. We don't have any service running, and we do one Kubernetes service filter anyway, and we don't have any replica set running. Right? Good. So let's create this one. Cube CTL -s. Okay, now the command again. First check replica set is running. Yes. Service is running, and this is the cluster IP. We have to remember that. Let me copy this. Copy this, and we have ports running. So I'll take any random port and run that exe command again. All right. This one. And first, let me change the cluster IP because I have copied it already. And take any, let's say, middle one. And before I do that, I have to do the logs also for each of these. So what is this? It's taking that thing. Okay. Temporal logs. And I want to change this with the new pod which got created. This is the first one. Remember, this is the first one. Control V. Correct. And come here. And this will be the second one. Second pod from that on top of this list. And this will be the third pod. What did I do? I copied here only by mistake. This is the third pod. Cool. Now take any random port and give the session affinity. It should always hit that port. All right. Okay, it's hitting this third port. So, but I have taken the second port. So, but it is in this port. Now it will always hit this port. You don't need 7 8 times. You can see, right? It's a logging hit here. It is not going to any other port like it was going to other port in the previous run without session affinity. So this is about session affinity. Now moving on, this we have covered. Now, what if you want to expose multiple ports? Um, why would you want to do that? One reason is you want to have some service available, HTTP and some more HTTPS also. So that's one reason to expose multiple ports from the same service. Now what we'll do is we'll enable HTTPS on the Spring Boot, like whatever applications have, we'll enable HTTPS also. Now, this will be accessible on 8080 and 8443. I think I have already done it. Let me check that out. Let me log into one of these ports. Which port was this? Take any port. I've given this. Let me do port here only. Get ports. Here. Let me log into one port. Cube CTL. Okay, let me do this. Control REXCC. And instead of doing curl, I am going to, sorry. What did I do? REXCC. And instead of doing curl, I will go to bash shell of this particular port. Bash. I hope bash is enabled there. Bash. Oh, I forgot to put -it. If you want to interactive mode, then you have to be -it. So I am inside the port now. So let's see if I have this local host colon 8080/tips. That should be there. So, okay, this is there. Okay, I think this one. Now let me see if it is there on 8443. I think I had it enabled 8443, and it should be HTTPS. Okay, because there is a certificate issue. There is a way to disable that certificate. I'm forgetting that. See, SSL, I have used SSL certificate for this. So we'll see anyway. I think there's a setting I have explained about. So this, okay, this service, I already have it working on two nodes, 8080 and 8443. Now, if you have your own service, and let's say Spring Boot service, then you can follow these documentations to, set it up on two different ports and enable HTTPS also. So I have given this documentation. I followed this. If you have service not in Spring Boot, in Python or in C# or any other language, or in Java only, but without Spring Boot, then you follow the corresponding documentation. Every of these technology has their documentation of how to enable, how to open more than one port, or HTTP port or HTTPS port also. Just follow that documentation. So what I had done was I had followed these instructions, made the code change, did the memory clean install, created the jar and everything, and tested it also. So it was working fine. And what we'll do is we don't need to change the Docker file, but we need to build it. So I have already done it. If you are using Minikube, then you have to do some infrastructure work. So and forget about that, because now I'm also not using Minikube. Because you have created a new application, you have changed the setup in your application, so you have to create a new image. Now what we'll do is let's go through this YAML. We have this YAML, and which is type service. Now this service, this is just a name, and in the spec I have two ports, HTTP on 80, and 80 will forward it to 8080 service. 8080 of my port service. 80 is on the service object, this service object, and it will be routing it to 80 on my port. 443 is on this service, it's HTTPS, and it will be routing to 8443. And this is a selector. I have given both ports. So I create a port now. So whatever selector I have given, I give that as a label, and same is a container definition, right? This is the image you should use and everything. So now let's do this. What's the file name? Two ports, same service. All right. Inside this, I have to exit out the port. So let me delete the existing ports now. Control C, Control C, Control C. kubectl get svc. I'll delete the service first. kubectl delete svc slash. Okay, it's already there. Then kubectl ports. kubectl delete port slash this. I should have given. You could give all the ports in one delete command itself, like this. What is this? Okay, I don't know what this did. Control V. Okay. I have this utility installed which auto complete, so that's causing problem. So let me delete that. Oh, this already deleted. The second one was this one, and third one was this one. So these ports got deleted. I don't have any more ports running now. Hey, a replica set I should delete, because if I don't delete it, next set it will start. My mistake. kubectl get replica set. kubectl delete replica set slash this replica set. My replica set is gone. Ports are also gone. So now get two container ports. It's the same thing which I showed you. Oh, this is what is this YAML? Sorry, no, not this. I wanted two ports, same service. Two ports, same service. So same thing. Service HTTP/AT routing it to 800, HTTPS 443 routing to 8443. This is the label which I have, and this is the port. It has same label as this, and this is the definition. So let's create this. kubectl create -f. Now let's see. I have not created replica set now. I'll create for end of service. So kubectl get pod. Okay. Okay. Oh, my mistake. I don't have the latest image 9.0 now. Either I can build it or I can change this to the latest only, because I have latest only. So, and latest also has the both ports enabled. So what I'm going to do now is I'm going to delete this port. kubectl delete port. This one. And I'm going to delete this service also, and then I'm going to change this. Okay. Because I'll be creating this service again. So kubectl delete svc slash. Okay. Now this was the file. So what I'm going to do now is vim I have the latest. You should use the proper versions. I made the mistake of using latest and I'm carrying over from that, but you should always 1, 2, 3 or whatever version. Each company has their version strategy. Like for mine, for major version, it should have 1 dot something. If you upgrade to if there's a major change, it should become 2 dot something. If it's a small change, then it should become 1.1 or something like this. So follow that versioning strategy. So now what I'm going to do now is I'm going to create this again. And let's get the ports. Service is running fine. Let's port. What is this? Let's check this again. Okay, let's check the images first. Docker image ls. These are the images I have. Let's see the image. It has the latest. It did not give the latest one. LATESR. This seems correct. Okay. Now let's see the code again. Maybe it's running fine. kubectl get code. kubectl describe I want to see what error it is having. Port slash. Okay, I don't have the same image name is incorrect. I think you are right. Image name is incorrect. Docker image ls. This was the image name. I'll just copy the same image name from here. This hyphen and all the things are mixed. Copy. I go here. Where is my VM? And I give the same image name here. Correct. Save it. Let's see the port. I'll delete this port. Controller. Delete the service also. Inside the service, delete the port also. Okay. I don't have any port. kubectl get port. Nothing. kubectl get service. Nothing. Only one service is there. Now what I do is I create it. Got created. So now I see get port, kubectl get port. Now it's running, and I can see kubectl get service. This is the cluster IP of the service. Correct. So we are able to create this. Now what we are going to do is it opens two ports, HTTP and HTTPS. And oh, you can see this port visible through this also. All right. See here, when I see get service, this service has two ports, 80 and 443. And so selector we already discussed, we did it. So we created this also. Now what we are going to do is I just wanted to skip the I just wanted to see that command where we can skip the cell side. This is the command which is getting. So -k, this is what I was looking for. So -k, if you do, it will skip the certificate verification, right? Because I'm using cell side certificate, so that's why it's causing problem. So what I'm going to do now is same thing. I'm going to use kubectl cube, or let me just do this exec controller exec. What is this? What I'm doing? Exec. So what I'm going to do is not this. This one I wanted. So I'll give this port which I have running. This is a port. So control V, and what I want to do, and this is a cluster IP. And it's running on port 80 now. So I can give 80 or I can skip this also. So I got this, right? Even if when a port is 80, you can even skip giving the port name. I think it will work. Yeah. So now what I will do now is I'll give -k and give HTTPS. And now port is 443. This is the line I'm following. The same cluster IP and the port 443 and it's HTTPS. Correct? Let's see. Cool. So it gave me this. So now we are able to see we created one port with two ports and a service which could access these two ports. One was on the service had 80 and 443. 80 was routing to 8080 of the port. 443 was routing to 8443 of the port. In production, in real applications, I have used self-signed certificate here. But in real applications, you will not be using the self-signed certificate. You will be using a real certificates. And because I am using self-signed certificate, so I had to give -k to skip verification of the certificate. So that's about using two ports. This we did. Now we'll cover only this. You can name the ports. So far we have been using the ports as is. You can give certain names to the ports. And why you want to give? Because sometimes remembering the port numbers could be difficult, especially while using non-standard ports. See, ATN 443 was easy, 8080 was also easy, but sometimes your applications or your systems might be using some port numbers which are difficult to remember. The port numbers are difficult to remember, but if you give the names, names are easy to remember. That's one reason. Other reason is that you can change the ports in port without changing the service, because in the port you will be giving the port number and the name, and you'll be referring that name only in the service. So tomorrow, if you want to change the port, you want to change the port to give different port, because now your service is getting exposed in different port. So you have to change only the port definition. You don't need to change the service definition. So this is what we'll use. So we have this, service definition, some metadata, and this is a name and the port and the target port name. And I think it's the same thing which we have seen. I think, let's see, whatever we saw here also. We have used it already here anyway, but let's see. This is the name HTTP open on port 80, and this target port here. The difference, the target port here, there in the previous definition without naming, we were giving 8080, but here we are giving HTTP. This HTTP is the name of the port, name of the port which have defined in the port definition. This is the name you have given. You could give any name actually. I have given same name, HTTP only, but this could be any name. Whatever that name is, you can define. You should define it here. Same with HTTPS. It's 443, and the target port is HTTPS. And this HTTPS is the one which I have defined here in the port definition, and it is 8443. So 443 will get repeated to 8443. 80 will get it to 8080. Tomorrow you want to change the port definition to have some different port, you just change it here, because you're given these names, and these names are getting referred in the service definition here, and here we don't need to change the service. Okay? So that's how. Let's go through this. We'll create this. I will not run this, but I think I have a file. So let's see Java service name port. I don't remember the file name, so that named. So port with name port. So these are the two YAMLs. This is the YAML I had, name ports with some same service. That YAML. Okay. Yeah, it's the same thing, right? So I have given. So I mean, as an exercise, you can try this yourself and see it working. And you can change. You can change these names also. Here I have given HTTP. You can change to something else. Change this to something. I'll put this as a homework, so you can do that yourself and see it working. And you can access the application using the curl command and the cluster IP and the curl command which I'm showing you. So that's about it today. I will stop it here. In the next session, we'll cover, okay, this we have done. Port discovering service via environment variables. So this is one thing. Discovering service via DNS. Then connecting to service outside cluster. It needs some infrastructure which I do not have on the laptop. So most of the time we'll, for this outside service, will cover the mostly theory. Yeah, so there are different ways of connecting, and there's a node port and the load balancer are the ingress. Node port, load balancer, ingress controller are the main things which you should be aware of, and we'll discuss about most of these things in the next session. So that's about it today.